Measurement Part 7 is brought to you by examfear.com. No more fear from exams. Please make sure that you have watched Units and Measurement Part 1 to Part 6 before going ahead with Part 7. Now, let us look at another topic, that is combination of errors. At certain times, we also need to deal with combination of errors or arithmetic operations over errors. We will see the scenarios in this case. There are three rules for combination of errors. The first rule states, when two physical quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. That means, let us suppose we have two quantities x and y, and x and y together form another quantity z. The rule says that in that case, the error involved in z, that is the absolute error involved in z, will be equal to the sum of the absolute errors involved in x and y. We will now see how. We are saying that z is a physical quantity which is the sum of two physical quantities x and y. Now let us suppose that x, the quantity x, involves an absolute error of delta x in its measurement, and the quantity y involves an error of delta y in its measurement. Let us suppose the quantity x involves an absolute error of delta x in its measurement, and the quantity y involves an error of delta y in its measurement. In that case, the quantity z will also involve some error, say delta z in its measurement. So we will see the relation between all these errors. So in that case, z plus delta z will be equal to x plus delta x plus y plus delta y. Correct? Now we can arrange this equation like x plus y plus delta x plus delta y. Now if we equate both the sides of the equation, we find equate both sides. What do we see? Z is already equal to x plus y. That was the given condition. Therefore, delta z has to be equal to delta x plus delta y. That means when two quantities are added to give a third quantity, then the absolute errors in the two quantities also add up to give the absolute error in the third quantity. Correct? So, we proved that when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Let us suppose we have two quantities x and y, and a third quantity z is equal to the product of x and y. Even here, we assume that x has some error, say delta x involved with it, y has some error, say delta y involved with it. So let us see here. So z plus delta z will be equal to x plus delta x into y plus delta y. Now we can write it xy plus x delta y plus y delta x plus delta x delta y. Now what do we do? Since delta x and delta y both are very small, we ignore this product of two small quantities. This term is ignored. Now we divide LHS by Z. We divide this LHS by Z. So we get 1 plus delta Z by Z. and we divide RHS. We divide this by Z and we divide RHS by XY. So we get 1 plus delta Y by Y plus delta X by X. Now this 1 and 1 will get cancelled. So we get delta Z by Z is equal to delta X by X plus delta Y by Y. So what did we prove? We proved that in case of multiplication, the relative error, because this is nothing but relative error. We saw the definition of relative error. It was the ratio of the absolute error to the actual quantity.